Exponential and logarithmic functions is Unit 9 of the course Applied Algebra or APA. Objective number 1, define and graph exponential functions. So this is the definition. An exponential function is a function that grows or decays at a rate that is proportional to its current value. It takes the form f of x equals a times b to the power of x, where a is a constant, b is a positive real number that is not equal to 1, and x is the argument of the function. So this is the graph of f of x equals a times b to the power of x. Its domain is all real numbers, meaning to say this graph extends infinitely to the left and infinitely to the right, and its range is y is greater than 0. So this graph here is from greater than 0 and extends infinitely upward, and its y-intercept is 1, this point here, and it has a horizontal asymptote whose equation is y equals 0, or the x-axis. Objective number 2, define and graph logarithmic functions. This is the definition. Logarithmic function is an inverse function to exponentiation. The logarithmic function is defined as for x greater than 0, a greater than 0 that is not equal to 1, y equals log base a of x if and only if x equals a to the power of y. Then the function is given by f of x equals log base a of x. The base of the logarithm is a, read as log base a of x. This is the graph of f of x equals log base a of x. Its domain is x is greater than 0. That means to say from greater than 0 and extends infinitely to the right. Its range is all real numbers. So meaning to say this graph extends infinitely downward and infinitely upward. Its x-intercept is 1, this point here, and it has a vertical asymptote whose equation is x equals 0, or the y-axis. Objective number 3, simplify logarithmic expressions using the properties of logarithms. So we have 3 properties here. The first one is the product rule. Log base a of x times y equals log base a of x plus log base a of y. We have the quotient rule. Log base a of x divided by y equals log base a of x minus log base a of y. And we also have power rule. It's log base a of x to the power of p equals p log base a of x. Example number 1. Expand log base 2 of m times n. So from our product rule, we can write log base 2 of m plus log base 2 of n. Example number 2. Expand log base 3 of p divided by q. By quotient rule, we have log base 3 of p minus log base 3 of q. Example number 3. Condense 3 log base 6 of x minus 4 log base 6 of y plus 5 log base 6 of z. From power rule, this 3 here is the exponent of x, this 4 is the exponent of y, and this 5 is the exponent of z. So it becomes log base 6 of x to the power of 3 minus log base 6 of y to the power of 4 plus log base 6 of z to the power of 5. So we can write log base 6 of x to the power of 3 plus log base 6 z to the power of 5 as log base 6 of x to the power of 3 times z to the power of 5. Now, because we have minus sign here, we can write y to the power of 4 on the denominator. So this is our answer. Objective number 4. Solve exponential and logarithmic equations. Example number 4. Solve 5 to the power of 2x minus 3 equals 125. In solving exponential equations, the first thing we are going to do is rewrite either side of the equation so that the bases will be equal. So in this case, we can rewrite 125 to 5 to the power of 3. And now we have 5 to the power of 2x minus 3 equals 5 to the power of 3. And we have equal bases. Since the bases are equal, we can just equate the exponents. So it's 2x minus 3 equals 3. Adding 3 on both sides, we have 2x equals 6. And dividing both sides by 2, we have x equals 3. Example number 5. Solve log base 4 of x plus log base 4 of the quantity x plus 3 equals log base 4 of 18. Now, from our product rule, we can condense the left side of our equation. So, since it's plus here, we can multiply x and the quantity x plus 3, and that gives us x squared plus 3x. Now, the base of our logarithm on the left is 4, and on our right it's also 4, so we can just equate x squared plus 3x equals 18. And we can rewrite x squared plus 3x equals 18 to x squared plus 3x minus 18 equals 0. And this quadratic trinomial here can be factored. So the factors of x squared plus 3x minus 18 are the quantity x plus 6 times the quantity x minus 3. Then we have here equals 0. And equating both factors to 0, we have x plus 6 equals 0 and x minus 3 equals 0. Solving for x on our first equation, we have x equals negative 6. And solving for x on our second equation, x equals 3. We know that x here should be greater than 0. So this means our answer is just x equals 3. Example number 6. Solve log base 4 of x plus log base 4 of x minus 6 equals 2. Again, by product rule, we can multiply x and the quantity x minus 6. So it gives us log base 4 of x squared minus 6x equals 2. Now we have logarithm on the left side, but on the right side we do not have. So the next thing you are going to do is to write this in exponential form. So this can be written as x squared minus 6x equals 4 squared. And of course, we know that 4 squared is 16. So we have x squared minus 6x equals 16. And we can write this in standard form. So it becomes x squared minus 6x minus 16 equals 0. The factors of x squared minus 6x minus 16 are the quantity x plus 2 and the quantity x minus 8. Now equating both factors to 0, we have x plus 2 equals 0 and then x minus 8 equals 0. Solving for x on our first equation, x equals negative 2. And then solving for x on our second equation, x equals 8. Now this x should be positive. So therefore, our answer is only this one, x equals 8. Objective number 5. Solve applied problems involving exponential and logarithmic functions. Example number 7. The relationship between the number of decibels B and the intensity of the sound I in watts per square meter is given by B equals 10 log times the quantity I over I sub 0, where I sub 0 equals 10 to the power of negative 12 watts per meter squared. Find the intensity if B equals 50. So using this equation here, we are going to substitute B with 50 and I sub 0 with 10 to the power of negative 12. So this is what we get. 50 equals 10 log of I over 10 to the power of negative 12. First, we can get rid of this 10 here by dividing both sides by 10. So this is what we get. And by quotient rule, we can expand this part here. So it becomes 5 equals log I minus log 10 to the power of negative 12. And we know that if the base is not written, it's understood to be 10. So this part here is log base 10 of 10 to the power of negative 12. And it is just equal to negative 12. So we have 5 equals log I minus negative 12. So that gives us 5 equals log I plus 12. Then subtracting 12 from both sides, we have log I equals negative 7. Writing this equation in exponential form, we have I equals 10 to the power of negative 7 watts per meter squared. So this is our answer. Thanks for watching, guys. This is Teacher Rejil. Keep safe.